Hello everyone. Today I would like to discuss on a technical topic of analyzing data with statistical regression, because everybody in this world now aware of the machine learning and its fast paced exciting field for like future minded people, and everybody knows that statistics is really boring, but the studious people in the field of data analytics who enjoy actual music of the field of regression and statistical model, they know better. But machine learning and statistics have a lot in common. In fact, they have the same ultimate goal. If you see in the model area in the real world system with mathematical relationships, mathematics and statistics, I mean the machine learning relies extensively on statistical model, the methods, the structure, the critical rules, the thinking. I mean the critical thinking in statistical area is actually really important. But I would like to discuss on the polynomial regression on my next stage, and fitting polynomial to the data. But you can easily extend the method of linear regression to polynomial. That is the process of fitting polynomial and set of point uses essentially the same process as that used to fit a line. Suppose I can write as, for example, you imagine like model equal to a into tf dot power of x comma 3 plus b into tf dot power of x comma 2. So why I am doing this? Because to obtain an expression for the loss, the module uses the same mean squared error. So this is actually a main topic of the polynomial regression. But if you see in another side of binary logistic regression, or the classifying data into two categories, where while linear and polynomial regression actually connected with identifying trends, and logistic regression still is concerned with placing data points into categories. Suppose I have a point of A and B belong to category X, and points P and Q belong to category Y. So what is the point? Actually, I am trying to focus is to setting up the problem. But binary logistic regression is concerned with testing the effect of one or two variables or more variables on a binary outcome. If patients take a new medication, will their symptoms disappear? Think in practical, think in a natural way, then apply to the technical area. Suppose if a candidate wears a red tie and blue pants on election day, will the public vote for that person? No. So actually, to demonstrate the process of binary logistic regression, this discussion focuses on a question of obviously importance, like how does the volume of my alarm clock affect my getting out of bed in the morning. So to examine the relationship between the alarm volume and my getting out of bed, I set my alarm to ring a different volume every morning for 40 days. Suppose I have 2 to 3 figures that illustrates the relationship between the alarm volume and my getting out of bed. So to model this mathematically, statistics area, and represent each category with a number. But I don't want the output to be limited to 0 or 1. I want a value between 0 and 1 that identifies the probability of me getting out of bed. This concept is important to understand when you code applications. When you actually go through the technical part of this topic, you will realize that I want a value between 0 and 1 that identifies the probability of me getting out of bed. So this concept is important to understand. when I or you code applications that perform classification, the theory of probability which takes center stage. So this type of discussion does not provide a complete discussion of the subject, but I will explain the mathematics behind of this and which is necessary for this technical motivation. So it should be clear that linear and polynomial regression won't help with this problem because their models produce values beyond the 0 and 1. Also, straight lines polynomials are too simplistic for the practical classification. So, to classify the data point, statisticians employ different type of regression which is called actual, the logical and logistic regression, just as linear regression model systems with a line with a polynomial regression which are uses actual logistic which implies a type of curve. So to define the models with the logistic function that plays a certain role in the application that classified the data points, and mathematicians express the logistic function like equation f of x equal to 1 divided by 1 plus e to the power minus x. So in this way, like its value is 1 and the maximum value is suppose 1 and the minimum value is suppose 0, and the function of standard deviation of 0 or f of 0 if you choose as x value as 0 equal to 0.5 actually, which implies that the data point in the center is equally likely belong to the both categories. So having selected a logistic function, you can imagine approximate the system with the model like mx plus b or standard deviation of mx plus b, and as with the linear regression, the goal is to find the values of m and b, bring the model as closely in line, so the real world observation as possible. And the next step actually to find an expression for the loss. And this is our last topic, that one possible method is to use the mean squared error and see the earlier section on the linear and polynomial regression. But there is also a problem. So for this reason, actually we use various type of tools, analytic skills. The goal of the binary logistic regression is to obtain the sigmoid function that best approximates the available data. So this function identifies the approximate probability of the point being classified like category 1, category 2 in this way. But the main concept of defining the model with the softmax function, we can also use the sigmoid function to classify points into two categories, but the section defining models with the logistic function for more information, like if a system such as MNIST classification is there and it has the more than two categories, the sigmoid function won't be sufficient. So instead of this, mathematician statistics use an operation that can accept an array of like softmax function which extend the sigmoid function to multiple values. So this is the main topic of today. Thank you so much. If you like this video, please share and subscribe.